Okay.
My internet's being a little weird, so I'm gonna apologize if there's like any future problems, but just a heads up.
Okay.
You like cover them.
Oh God. Just yeah. Okay. Avantika, you can like get started while I push this poll out, bro.
Okay. Well, an icebreaker. I was just gonna.
Meeting, for example.
Hey guys, make sure you're muted. Thank you.
Okay. So same thing as usual. We're gonna have an icebreaker, and then our first activity will be kind of like a Kahoot style, but on like the slides, because I know last time there were a few hitches, so I wanted to avoid that. And then activity 2, we're gonna be doing a practice exam, and then all of us are gonna answer any questions that you guys still have at the end. Yeah, so I feel like we talked about this a little bit already, but on a scale of 1 to 10, how are we feeling about the exam? Oh, okay. I feel like everybody's like averaging like 5, 6, which is pretty good, honestly. But if you're not feeling too good, if you're not feeling too good about the exam, don't worry. Hopefully this session clears up some questions and concerns. Yeah. Okay, so let's get started. First question is, what is the molar mass of NaOH, sodium hydroxide? So you can just drop the answers in the chat if you want. Yeah. What do we think? I'll give you a few minutes. I know there's some calculation involved, so you might want to pull out your calculator and maybe also like a periodic table. Okay, I see one person said B, somebody else said 40, okay.
23 plus 23 plus.
Okay, I see a lot of B's. Yeah. That is the correct answer. Does anybody wanna? Yeah, if all of you could just mute yourselves, that would be great. Yeah, make sure your mic isn't on, but yeah, does anybody wanna explain, or is anybody confused about this question? Oh my God, I'm sorry. Oh God. Sorry. Let's go back. Yeah, is anybody confused about this question? How many? Yeah, I can go over it. So, let's start off with, can somebody tell me how they approach this problem, or does somebody want to like walk me through it? Yeah, don't hesitate to ask questions if you're not sure. Does somebody want to walk me through this problem, like how they approached it?
So, I mean, you look to the periodic table to get the molar mass of each element in that molecule. So you look at it for sodium, then you look at it for oxygen, and you look at it for hydrogen. So, I mean, fairly straightforward after you reference the periodic table. So sodium, if you look at that, is 22.9. Oxygen is 15.9, and then, or 16, and then hydrogen is 1. So you just sum them all up and get around 40.
Yeah, Yeah, that's really good. That's exactly right. So we know hydrogen is 1, right? And then I believe sodium is, I think you said 23.
Yeah, about 23.
And then oxygen is 16. So if you just add all of this up, you should get 40. I think if you use the exact numbers, it'll be like 39 point something, but I just wanted to round it off. But yeah, does that make sense? Did that answer your question? I'm gonna take the silence as a yes. But if you have any questions about this, don't hesitate to ask any of us. Yeah. So moving on. Oh my God. Okay, I'm so sorry. I just have like a million things on my like screen. Like I'm looking at the chat and then I'm also annotating. So if my screen moves a lot, I apologize. Okay. So here's the next question. Which of the following is a combination? Yeah. If you're silent, I'm gonna assume it's a yes, but yeah. Which of the following do you guys think is a combination? I see a lot of A's in the chat. Okay. Does anybody want to like explain why they didn't choose the other ones?
Sure. So, okay, I'll just start off with B since we know A's, right? So if you're looking at B, you can see
Mhm.
that it kind of separates into 2 compounds. So that's how you know it'd be decomposition. And then if you look at C, it splits off into what do you call it? A double replacement. Well, actually, wait, no, single replacement. Sorry. Yeah, I believe. Yeah. So if you look at that, and if you look at A, and you see that A just combines, so you know A is a combination. I don't know if that really explains it, but if you can see an A, it merges into H2O rather than just being H2O2. So
Yeah,
boom.
that's a really good explanation. So yes, B is decomposition. I don't think C is double replacement or whatever you said. I think it's also decomposition, but Gabe and Liana, feel free to correct me if I'm wrong. Yeah. Can you clarify about what?
Oh, me for C?
Oh, no. I'm sorry. I
Oh,
was
sorry.
typing it in the chat, but
Okay.
I'm just gonna type it out. So somebody wants me to explain this question again. I can do that. Let me know if you have a more specific question about this question, but so basically, combination is when two, yeah. Okay, so as you can see, Liana put something in the chat and it's basically when 2 compounds form to make one, yeah, to make one product. Hopefully that clears it up. So, yeah, so Liana's saying the one she put in the chat would be the double replacement. All good. No. Yeah, so exactly as Ephraim said in the chat, combination is when 2 reacts combine to make one product. Does anybody have any questions about that? I think we'll do more of the other reactions, so like you can help differentiate between the two. No, so B and C are not double replacement. B is decomposition. Can somebody tell me why they know that B is decomposition? Yeah, exactly. So you have one reactant, but more than one product. So that's how you identify decomposition. That's correct. Okay, if nobody else has any further questions, I will move to the next one. What is a single replacement reaction? Here are your choices. I see a lot of C's. Okay. Yeah, I see a lot of C's. That is correct. Yeah, I don't know what more to say about single replacement because this is just like the definition. Yeah, so let's move on to the next one. What is the law of conservation of mass? Which one of these choices do you think best defines what the law of conservation of mass is? Yeah, I see a lot of A's in the chat, which is correct. This is really important. Oh, okay. So Mandeep says IDK. Okay. Let's. It is A. So that's basically you cannot create matter, nor can you destroy it. This is really important in like chemical equations. Like when you're balancing equations, for example, the reason you balance them is because like you can't have more on the reactant side than the product side. That would, go against the law of conservation. Does that make sense? Does anybody have any questions on that? Okay. Yeah. Okay. Identify the states of matter. So this would be like, little, in like chemical equations where you put like, is it a solid? Is the compound a liquid? I see a lot of C's in the chat. Yeah. Yep. C is correct. I feel like aqueous is one that people miss a lot, but can anybody tell me what an aqueous solution or like what aqueous is basically? Somebody said water dissolves in water. Yeah, so it dissolves in water, and as a result, what happens? Something to do with charges. Like, for example, oh my God, that is horrendous, but like that. Not necessarily neutralizes, but I was trying to get at the fact that like there's ions. Yeah. So aqueous solutions basically they dissolve in water to form ions. So that's what's important about aqueous solutions. It doesn't really neutralize, or you could think of it as dissociating. Okay, next question is, I'm gonna give you a little bit more time on this one. But yeah, basically, what is the Lewis dot structure for this CO3 2 minus? I'm gonna let you like draw it by yourself, and then in like 2-3 minutes, we'll come back, and then I want all of you to like walk me through how to draw the diagram. Did somebody have a question? Did I speak over somebody? Okay, how are we feeling about this question so far? Are we like almost done? Are we still like working on things?
Do you need the 2 minus around the structure, like in the
Yeah, it's
brackets,
I'm sorry.
like in the brackets?
Yeah, it's around the whole, it's like CO3 2 minus, so it's not just like, it's for the whole compound, if that's what
Right,
you're.
right. But when it's written, it's supposed to be written like, and then like Lewis dot.
It's like the. I'm sorry, can you repeat your question? I don't think I heard. I thought you meant like the 2 minus.
Yeah, I know what you're talking about real quick. And yeah, you're right. It's like put the brackets around the entire Lewis structure and 2 minus to indicate
Yeah.
that it's, yeah, you're right.
Okay, cool. But the contents reflect that.
Yeah, the everything inside should like remain the same regardless if you do the brackets or not.
Okay, cool. Thanks.
Okay. Does anybody want to walk me through this?
Let's just start with the first step.
Mhm.
I can try.
Okay, sure.
Can you hear me?
I can hear
Okay,
you.
okay. Just making sure. So what I first did was I looked at how many valence electrons I had in total, so I knew how many I need to have in the end. So carbon has 4 valence electrons, and oxygen has 6. But since there's 3 oxygen, that means that there are. I did not count this. I don't want to get this wrong, but 6 plus 6. There's 18 electrons. Yep.
Mhm.
And so in total, you should have 24 electrons because the -2 means that you're gaining 2 more electrons in this equation. So you, in the end, you should have like 24 electron groups.
Yeah, that's a really good explanation. Yeah, good job. I'm impressed. Okay, so yes, in total we have, I think you said 24, 20 something.
24. Yep.
Let me just, sorry. Let me see if that's right. I trust you, but I just want to make sure. I think it's, isn't it 30? Am I tripping? Yeah, I think it's 30.
Oops. My
You're
bad.
good.
I kind of rushed with the math.
You're
Yes.
good. I think it's just like an addition. Yeah. So it is 30, but you got all like the major steps correct. So now that we know there's 30 valence electrons, how would we start with the Lewis dot structure? Yeah. So people are saying the central atom is carbon. Yeah, so this is our central atom. We've identified it. What do we do next? Oh my God. I'm so sorry. My drawing skills are subpar to say the least. But so I see surround the C with 3 oxygens. Why did we have an extra 6?
Yeah, I'm a bit confused about it as well. Wouldn't it be 4 plus 6 times 3 plus 2?
What about the oxygen though? Oh wait,
Yeah,
no.
6 times 3 for
You're
oxygen
right.
plus
You're right.
4 for carbon. Okay.
Okay, you're right. I'm sorry. That was my bad. Yeah, let me just fix this real quick. So, it's supposed to be 18 plus 4 plus 2. I'm trying to like look at the chat at the same time that I do this. That's why I'm just, yeah, okay. So 18 plus 4 plus 2. Yeah, so it should be 6 threes plus 4 plus 2. So I think you're right, it is 24. I'm so sorry. That was my bad. I apologize. Okay. So now that we know there's 24, how do we start? So like, what do I do next? I see somebody said bonds. Yeah. So we know carbon has 4, right? So how many does carbon need to be happy? I see somebody said 8. Yeah. So for the bonds, how would I like, do the bonds? Like, what do I do?
Line.
Yeah, okay. So you draw, so this is how you like indicate a bond, but now carbon has 2, 4, 6, and we said carbon needs 8 to be happy. So what do I do? How do I make sure that carbon is happy? Okay, Fatima says add an extra bond. Yeah, octet rule. How would I do? Okay, so if I put 2 more like this, is that good? Yeah, because now carbon has 2, 4, 6, 8. Does that look good to everybody so far? Okay, if anyone is lost or has questions, feel free to ask. Yeah, and I can clarify. So oxygen also needs 8, right? To be happy. So 2, 4, 6, 8. 2, 4, 6, 8. How do you know when you add another bond versus a lone pair? That's a really good question. So if you can see right now, like, doesn't this have a double bond? Okay. So the way you would determine is you have to count the number of valence electrons. So in this case, we know we have 24, right? So we want to make sure that all of them have 8 to be happy. So 2, 4, 6, 8, and then times 3. Yeah, yes, one line does mean that 2 electrons are being shared. So 2, 4, 6, 8, right? And then all of these have 18. So are we over electrons or do we have the right amount? Because we know there's 24 in total. Yeah, exactly. That's why we know that there's these lone pairs. That's why we know that there has to be another oxygen and carbon bond. Oh, sorry, kind of messed that up. But now, how many are there? Let's actually take one out. Hold on. 2, 4, 6, 8, 10, 12, 14, 16, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Why does the line count as 2 dots? I thought it was only 1 per dot. Okay, yeah, what Liana and Gabe said. So can somebody tell me, what I'm doing wrong here?
I think it's right.
Okay, there we go. Okay. Wait, why did I count 22 then? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oh, yes. Okay, there's 24. I was like, why are there not 24? I was so confused. Okay, yeah. So there's a double bond. Yeah. What I like to do is what we did before, where we put all like we made sure everybody, like each of them had 8, right? And then we then saw if there's like any discrepancies. So we noticed that the lone pair on carbon was like, we had extra. So then we rearranged, if that makes sense. Can anybody tell me like if there's like an element that isn't happy with 8, that maybe needs less? What are the exceptions? I see hydrogen. Yeah, how many does hydrogen need to be happy or content? Yeah, it's 2. So just something to keep in mind when you're doing these. That not, I think hydrogen might be the only exception. I might be missing one, but wait, why did you start with carbon with 8 electrons if it only has 4 on the periodic table? Okay. Okay, so it became a double bond because otherwise, if carbon had a lone pair, right, then carbon wouldn't be, we'd have more. So say we got rid of this, right? We got rid of the double bond. Like previously we had a lone pair, right? Now how many how many do we have now? Because previously, right, there was just, because then oxygen doesn't have enough. Right now, if this is the case, everything has 8 and carbon has a lone pair, but now we're going over 24. Does that make sense? Okay, good. Why did you start with 8 electrons for carbon if it only has 4 on the periodic table? So carbon does, that's the number of valence electrons, right? But is carbon happy with 4? What does the octet rule say? Yeah, somebody just said 8 to be complete, which is correct. So the octet rule says that for the most part, all elements want 8 valence electrons. That's like, they're stable. They're always yearning for like more electrons and to have 8, if that makes sense. Okay. Hopefully that cleared up the confusion. Let me just erase this so there's no confusion. This is wrong, just so everybody knows. There is a double bond and then you have to get rid of these 2 right here, but there you go. Why don't we give them all double bonds? I'm sorry, I'm not laughing because that's like a bad question, but that is a good question. Why don't we give them all double bonds? Well, we don't need to, right? Because like what would happen if we gave them all double bonds? Like carbon would have more than needed, right? Does that make sense? Yeah, carbon doesn't need more than 8. Yeah. Okay. There would only be 12 in the whole thing. I'm not sure what you're referring to. If you could clarify what you mean by, oh, you were just answering the previous question, I'm guessing. Okay, yeah. Okay. If nobody has, if everybody's like clear with this one, we can move on. I don't see any more questions in the chat, so just gonna erase. Okay. Identify the list of common polyatomic ions. This one's a little bit straightforward, but I do think it's something important that you should know. I don't know if I don't know if like I haven't taken this test before, but Liana and Gabe could talk about it if they want, but I feel like common polyatomic ions, especially for like naming them or like just being familiar is good on the test. Yeah, I feel like it'll be helpful.
What's the extent of the sheet reference sheet that we have?
I know you get like solubility rules, but I'm not sure what
Yeah.
else. You
Uh,
should get a periodic table as well. But
In the email, she had a section where she told you everything that's going to be on there. So just look back at that, should be there.
Okay, I didn't realize there was an email. I'll look out for that.
Okay. Yeah. Okay. Fatima says the polyatomic ions will be provided. Sounds good. Yeah, the answer is C. I see a lot of C's in the chat. That is correct. Okay, the next question. How are covalent bonds different from ionic? I see some discrepancy. Yeah, take time to read this one. I know there's like a lot of words, but yeah, I see a lot of B's. It is B. That is correct. Does somebody want to explain how they like think about this or like how they memorize this?
How'd you guys come to be? Or did you guys just like look at your notes? If so, what do your notes say?
I just personally remember this as just sort of a definition kind of thing, that ionic bonds have they don't share. It's like a handoff type of thing. Whereas covalent bonds, also the covalent bonds, that's why they tend to be, I think, weaker than ionic bonds due to sort of how they share electrons. So that was sort of the way I thought about it. But I think for the most part, for me, it was just definition.
Yeah, it's a short version. Like you can literally just be like covalent bond, they share, while ionic, they basically just transfer or take it entirely, right? So one steals, one shares. There you go.
I do think though, if I remember correctly, I think covalent is stronger, but you don't need to know that. Like you don't need to know that deep, but yeah.
Also, I do have a hint, like a tip that could help. This might be more complicated, but if it helps you, it's good. Covalent bonds, since it starts with a C, you can think of it as like carbon, and covalent bonds happen a lot with carbon interactions, or sorry, carbon with like oxygen, whatever, right? So like that last example we did, that carbon and oxygen, it was a covalent bond because it was sharing, right? And that happens a lot with like carbons versus like ionic, it's like sodium chloride, like NaCl, it like completely steals the electrons. So you can kind of think of it as like covalent carbon, if that helps you. Helps me.
Also, this tends to be reflected in the electronegativity, doesn't it? That ionic compounds tend to have a bigger discrepancy between the two.
Yes, absolutely.
But I don't think that you need to necessarily know all that for like in terms of like that they have like a bigger electronegative difference. I don't think you need to know that for the exam. Correct me if I'm wrong. But the way I like to think about it, which is really like basic and is like ionic always has charges. Like when I think ionic, I think charges because they're usually in like solutions. Yeah, I think charges, and then covalent don't really like you'll never see the elements separately with charges like this. That's how I like to think about it, but yeah. Okay. Moving on to the next one. How many valence electrons are there in water? Oh, I see a lot of varying answers. I'm gonna wait for a few more people to chime in. Okay. Does somebody want to explain how they did this problem? Two H 1 + 1 + 6. Yeah, so hydrogen has 1, so there you go. We have 2. If we have 2 hydrogens, we have 2 from each hydrogen. 2 valence electrons from each hydrogen, and then oxygen has 6. So that's how we get 8. Do you have any questions on this one? How does O have 6? That's a good question. Okay, so can anybody like tell me how they figured out that oxygen has 6 valence electrons? Yeah. So if you remember from early on in the semester in the periodic table, certain groups have certain number of electrons. So just make sure you know that. Yeah, oxygen is from group 6A, and everything in 6A has 6 valence electrons. Okay, let's move on to the next question. Identify the covalent compound. So chlorine dioxide. Which one do you all think chlorine oxide is? Yeah, I see a lot of A's. That's correct. Does anybody have any questions on this? This is pretty straightforward, but I can understand how like naming or like identifying compounds can be difficult. Yeah, Haru, do you want to explain what you don't understand about this one? Do you want to tell me in the chat? Yeah, so does anybody want to explain how they thought about this?
Well, I mean, I guess like it's di is one of the prefixes for 2. So chlorine, because it has no prefix, we assume it's 1. It is a 1 element. So like only Cl1. So that eliminates B. And then the di eliminates C and also eliminates D because it's not tri. So you're only really left with A. So it's
Yeah.
chlorine dioxide, 2 oxygens.
Yeah, that's a really good way to think about it. Definitely go over naming conventions for the exam. I mean, I don't know that she'll give you anything too complicated, but definitely good to know them. What is the difference between bond polarity and molecular polarity? Okay, I see one person said D. Yeah, D is the correct answer. I don't really know what to add to this, but yeah, that's correct. Okay. So bond polarity versus molecular polarity. So molecular polarity, I feel like I'm trying to think of an example where I could give you, like, show you the difference, but I can't think of like one at the top of my head. The answer is D. Wait, Gabe or Liana, can you guys think of a like example? If you guys remember like the molecular polarity like questions, you're usually given like a number, right? Do you guys remember the scale for
Yeah, you
molecular?
can pull it up right now.
Okay.
Yeah.
You can share it.
Yeah, I can stop sharing.
Okay, give me a sec. Too many documents. Okay, it's fine. So I'm gonna pull up a bond polarity. Okay, so for bond polarity, I'm gonna share my screen really quick. So for bond polarity, the key thing is the electronegativity. So actually here, I'll search it. So you want to look, which you'll be given an electronegativity chart, but they look essentially like this, where it's the same thing as the periodic table, except you have electronegativity values for the elements. And so essentially what you would do, oops, for example, the problem that we're like dealing with, let's say it's like CH4. Oh my God, why can I not? It's fighting me. So let's say I'm going to put in the chat. The compound we're trying to determine the bond polarity for is CH4, which is just one carbon in the middle, 4 hydrogens all around it. So when you're going to be given something like this, it's going to be really easy, like something where all the bonds are the same, or otherwise you would specify like the bond between this and this, right? So the way you would do this is you look at the electronegativity of carbon, which is 2.5, and then you're going to subtract 2.1, which is, sorry, 2.5, which is the electronegativity of hydrogen. And then that would, just subtracting the two would give you the difference. And then that would be the bond polarity. So the total polarity of a carbon to hydrogen bond would be what?
.4.
Yeah, exactly, 0.4, right? Because all you're doing is just subtracting the two. It's really easy. So that's how you would determine that. And there is a, hold on, let me also find that. She will give this to you, but there's like a picture. She probably showed it to you during, it's like this, during the lecture, where it's essentially whichever difference you calculate. So for example, we calculated 0.4, right? In this chart, you have from 0 to 0.4, 0.4 to 1.8, and then so on and so forth. But the numbers are going to be slightly different because chemistry is weird. Everyone kind of does it differently. But in this instance, we calculated 0.4, which is right on the verge of nonpolar and polar, but it is going to be a nonpolar bond. So essentially, after you calculate that number, the difference, you would look onto this table that's given to you, and you would determine where that number lied and if it was a polar, nonpolar, or an ionic bond. Does that help for bond polarities? All right. Do you also want an example of a molecular polarity? So Edward, I'm hesitant to say yes because the chart she gives you is slightly different. Like I think the difference between polar and ionic is 1.9, I'm pretty sure, instead of this as 1.8. And maybe between nonpolar and polar, it could be like 0.3, 0.5. Sometimes the numbers change. So you don't need to memorize this. Just make sure to know how to use the chart and use what's given to you on the exam.
I believe like she has the chart that she uses in one of her lecture notes. So I
Yeah.
think look on Canvas and you'll find it.
Yeah, do you folks remember what I forgot, I remember someone in the lecture had asked, but do you folks remember what the I don't know if she'll even give something like this, but in the test, but if like it's on the border between say non-polar covalent or polar covalent and ionic, do you folks remember sort of what the determining factor was?
Yeah, so rule of thumb is round down. Like in this case, it landed on 0.4, but I know for a fact that C to H bond is nonpolar. So if it's on the cusp, think of it as the smaller one, if that makes sense.
I see.
Yeah.
Okay, thanks.
Rule of thumb. I'm just saying. I hope she doesn't give one where it's like on the line, because yeah, it's like, what are you supposed to do? But yeah. Okay, so for example of a molecular polarity, I want you all to give me some like identifying factors. Like what do you look for when you're dealing with molecular polarity?
Is the molecular polarity like the shape of the geometries? Is that?
Yeah, that has to do with it. Geometry.
So then it's lone pairs versus bonds, right?
Yeah, lone pairs are involved in it. There's a lot of things that go into it. So, but we can quickly talk about this one. So we'll do the same example. And essentially, right, CH4 looks like this. Does anyone remember the name of the structure that this is?
Is it
Tetrahedral.
tetrahedral? Yeah.
I heard people say tetrahedral, right? Yeah, exactly. Perfect. So this is a tetrahedral. And what is some things about a tetrahedral? Is it symmetrical, non-symmetrical? Yeah, right. Just by looking at it, you can tell it's symmetrical. So symmetry is a huge thing when it comes to molecular polarity, because if we really think about what polarity is, does anyone know like what the actual definition of polarity? Because like we have bond polarity, molecular polarity, but what does it really mean?
I'll give everybody a hint. It has something to do with attraction.
Is it like it's like how much molecules or atoms are individually attracted to one another, right?
Kind of. That has to do with electronegativity, which kind of relates to polarity. But think about it like this. We have poles in the earth, right? Like North and South Pole. So those poles, they're like the most opposite apart from the earth, and they also have different charges, right? Like the North is positive or negative. I don't remember which is which, but so Edward said nonpolar has equal attraction, polar doesn't have equal attraction. Yes. So that's a great explanation. But so what that really means, right? Polarity is about separation of charges. So think about it like the poles, like North and South Pole. They both have different charges, right? And so the whole thing about this is to determine where exactly the electron is. So for example, when we're talking about bonds, you have your carbon-hydrogen bond, C to H. We calculated that this is nonpolar, which means that the electron is equally attracted to both carbon and hydrogen, like Edward said. So the electrons are essentially like kind of right in the middle. They're equally attracted. However, if you have an ionic bond, such as like NaCl, which is the most common one, chlorine is way, way more electronegative than sodium. So they don't have equal attraction, and this is polar, and like the electrons are like really close to chlorine. So chlorine is going to be more negative. Oh, sorry, I wrote positive sign. Chlorine is going to be more negative than sodium. So that's essentially the like background behind this. So now when we look at a structure, we're essentially trying to figure out if the electrons are evenly spaced in the structure. So in this instance, since this is symmetrical, there's no lone pairs, which would like, if there's electrons here, obviously this side would be more negative, right? But we don't have that. So do you think this is going to be polar or nonpolar? And remember, think about what Edward said. Nonpolar has equal attraction everywhere, and polar does not. All right, we got 3 guesses for nonpolar. I'm going to try to get a few more.
Are you asking about sodium and chlorine?
No, sorry, I'm asking about CH4, this one.
Oh, okay.
Yeah, so everyone's saying nonpolar. You're correct. This is nonpolar, right? Because it's symmetrical. So all the hydrogens are equally balanced with the carbons, and they're also equally balanced with each other. And if there were to be lone pairs in this example, like let's just draw some in and see how it would change it. So let's say this is not chemically possible, but let's say this hydrogen had a lone pair. What would this change to be? Would it still be nonpolar? No. My dots. Or would this become polar? Okay, Brian says polar. Yeah, right. It would be polar because immediately just the addition of this lone pair dramatically changes, right? Because this entire side now is heavier with electrons, so it's going to be negative, versus the rest of this is going to be positive, which means it's going to have a polarity, right? It's going to be unbalanced. Alrighty. Are we feeling better about this? Should we move on? All right, awesome. I'm gonna stop sharing. Yes, of course. I'm glad it helped.
All right, so we're about an hour in, and what we're gonna have y'all do now is take a practice test. So I'm gonna give you guys 30 minutes. There's less questions on this than there will be on the exam, because you have 50 minutes for the exam, so we tried to make it like, I don't know, like kind of even that in that way. So we'll give you guys 30 minutes to do it, and then I want you guys to pay attention to the questions that you either skip or don't know what to do on them. Keep the number in your mind, and then we'll come back and try to do those questions like step by step. So let me send you the link in the chat. Or at least I was gonna do that until I saw that I can't minimize my screen or like go anywhere else. I don't think. Oh, yes, I can. Never mind. I lied. Give me a sec.
Do you want to just share the link to the doc in the chat and then?
I just need to get the link.
Oh, I can do it if you want.
Awesome.
Yeah, I got you.
I got it.
Even awesome. Wow, that was quick. Okay, cool. Yeah, so there's a test.
Thank you.
I'm gonna start a timer right now. I'll start the timer in like literally 1 minute. So from 1 minute from now, you'll have 30 minutes to do this practice test. Okay, ready, set, never mind. Hold on.
Sorry, 1 second.
Hold on, let me
Okay.
do it so that anybody that you. Oh my.
Hey,
wait,
Gabe,
wait,
quick
what are
question.
you-
here,
Wait, does someone have a question?
Yeah,
Yeah.
I was gonna ask you a quick question here. I think you took the class most recently, but these questions are always sort of like sketchy. But like, what do you think about the overall difficulty of, because I think she like presents like a lot of material in the lecture, but then the test obviously only covers like a certain aspect of it.
Mhm.
And like I thought the last test was such that like we didn't really have any concepts that I felt were like super like like needed like multi-step kind of thing. In your experience, what was the second test like? Because there are a lot more things, I think, like a lot more of the concepts are more complicated and need like
Mhm.
3, 4, 5 steps to solve. So yeah, what was your takeaway from the second test?
Yeah, so
Like,
listen,
what do you
like
think an overall
so like the problems that are gonna take you the longest, right? So I'm thinking like stuff like really stoichiometry, I think would take the most steps, but there aren't gonna be a lot of like the problems that are gonna like take multiple steps. There's not gonna be like an overwhelming amount of them, right? Like it will be how was it? Because how do I say this? So it's set
like,
up.
we're time pressured, right? So like, because some of the questions she goes over in class, granted she slows them down, but even if you sort of like resolve them later, I mean they do take some time. So like a few minutes, right? So
Yeah, because like what she emphasizes is like for you guys to practice the stuff that takes a while to do so that you can solve them really fast. That's kind of what she pushes. So it kind of, to be honest, like, yeah, it depends on how fast you can solve it, really. But there aren't going to be a lot of those kinds of problems, right? Does that make sense? Like, there's not going to be a lot of problems that you're going to have like the multi-step thing, but when you do come across them, you do need to be able to solve them fast for time limits, right?
Sure. Okay.
Yeah, okay, so.
Thank you.
That's what I would say about that. Yeah, once it gets to like the practice test on Canvas, it's gonna be very much like that. So, yeah. Do you guys have access? Are we good now? Yeah, okay. All right, you guys can go ahead and start. You guys have until, I'll just start timer now. You guys have start until time. You have until 1:33. I can't speak English today. Yeah, I'll shut up now.
Hello, I have a question.
Yes. Speak now, and I might have an answer. I'm not hallucinating, right? Someone just said they had a question, right?
I heard it, but I also hallucinate. How'd I know?
Yeah.
Okay. Well, if you have a question, put something in the chat or say something.
Sorry, I can't make heads or tails out of the question 12. Looks sort of
Sorry, what was that?
inconvenient. Sorry, yeah, question 12, I can't really make heads or tails out of. Is it Cl, like for B, is it supposed to be Cl2 plus 2E turns into 2Cl minus, or and
Uh,
for
Wait,
yeah,
give me a sec. Let me
it's
look.
missing like missing arrows, I think, but maybe I'm wrong. This is the last page. Right before 6.4.
Oh, question 13.
No, 12, A and B.
Oh, A.
Both. At least the maybe when I printed it, it got messed up, but yeah.
Oh, yeah. I think there's supposed to be an arrow.
Yeah, so just where would that be? Would it be between the
So,
two
okay,
E?
I'm editing the document now, but it should be like right. So for A, it should be after the SN,
Okay. Okay, that's
and then for B, it should be after Cl2 plus 2E.
okay. So after the 2E minus, and then on the A after SNS
Mhm.
solid. Okay,
Yep.
okay. Thanks.
All right, y'all got like 3 minutes left. Oh, and remember to keep in mind questions or the number of the questions you want to go over. All right. The time is 1:33. So will there be an answer key? So I'm gonna make you guys a deal. I don't have an answer key, but if you guys want an answer key, email me after and I will make one.
I was
Okay, so
thinking we could just, as we go over the answers, we highlight the answers and then have them. That's the answer key. If you want.
what can you say again? I didn't get that.
Oh, we could potentially just like as make a copy of it. So that's the original. And then as we go through it, we just highlight the answers and then 2 and 1.
Okay. Okay, so first I'm gonna ask, how did that test feel? Scale of 1 to 5 of difficulty.
I was
also-
gonna say like, and this was gonna kind of relate to my other comment, but like I feel like the harder parts, like the more calculation heavy parts. I mean, they were all sort of in the back. I mean, I don't know that they're necessarily harder, but like they're more towards the back. So yeah, I mean, I think the front part's pretty easy. Like it's like conceptual mostly. The
Mm.
calculation part, I don't know that it's necessarily harder, but it just takes more time.
Got it. Okay. See what else we have in the chat here. See a lot of 3.5. It's just an interesting number. Okay. 2.5. 33. Okay. All right. Anyone else? Any comments? Did everyone finish on time? That's what I'm curious about.
I didn't get to the last one, the 18.
Okay, it's those last 3 questions too. Okay. Do you guys need more time? Yeah. Okay. How's like 5 minutes? More, less, hopefully less.
That works for me. That's perfect for me.
5? Okay, 5 minutes. Okay, maybe it's 5 more minutes, and then we'll go over it. Oh, right. So hopefully that was enough time to finish. We're gonna go ahead and get started with we'll start working through the problems and going over the answers. So you gonna share it?
All right, so we're gonna go over the first part. So 5.1. I know this section was a bit easier, so we're gonna go a little bit faster. What did we get for number 1? Put it in the chat. All right, we got a lot of people saying C, which is 5, which is correct. So good job. I'm gonna highlight it. Does anyone want to explain how you find valence electrons? Group? Yeah, group number. Yeah, the group number on the periodic table, right? You just count what group it's in, and then that's how many valence electrons, except for transition metals, right? All right, awesome. Any questions on this one? Or is this one super easy? Can I get some thumbs ups if you want to move on? That's fastest because we have a lot of people. Thank you. All right, let's go to the next one. Number 2. What is the most common ion phosphorus mix? What did you all get for this? All right, we got a lot of A's, a lot of -3s. So those of you who said A, why? What makes you like no, -3 is correct? Yeah, it is based on its charge, right? Because the ion is a charge. Yes, group number -8. That's probably the easiest way to explain it. So thank you, Mandeep. So, right, octet rule is always something that should be in the back of your mind when you think about chemistry. And so we already figured out that phosphorus has 5 valence electrons, and we know it wants 8 total, right? So that's how we know that 3 is correct. But also not just that, if you look at the group number, it's 3 spots away from the closest noble gas, like Edward said. So you can think of it either way. But yeah, that's correct. Alrighty, any questions? Or can I get some thumbs ups if you're ready to move on? Thank you. Alrighty, let's go on to 5.2. So select the correct formula for each of the following compounds. So for A, you're going to combine sodium with a +1 charge and sulfur with a 2- charge. How would you put those two together to form a compound? A lot of people said B. Okay, those of you who said B, would you care to explain why? Yeah, the charges need to cancel out. Exactly, right? So we know sodium has a +1 charge. Sulfur has a 2-. So to be neutral, it has to be B. Good job. All right. Any questions? This stuff is pretty self-explanatory. Once you see it, you start registering it and you're like, yeah. Yes. Okay. Mandy, you bring up a good point. The easiest way to figure out like charges and like balancing the charges is to actually just switch the charges and put them as a subscript, right? So what that means is sulfur has a 2 charge, which means the easiest way, right? It's like multiplication or lowest common denominator, essentially. You're going to put that 2 in next to sodium, right? Because 2 and 1, it just works that way, right? You just switch it and then that's like easy. All right, good job, good job. All right, let's go on to B for aluminum and chlorine. What did we put? A lot of A's. And essentially the same thing as last problem. So good job, you're all correct. A is correct. And right, again, we can see this is the same thing where you can flip the charges. Oops, the L. You're very right. That was my bad. Thank you. Yeah, so Al3, you're going to need 3 chlorines to neutralize that 3+ charge. All right. How are we feeling about these? Easy questions? Give me some thumbs. Thank you. Thank you. All righty. We're going to move on to writing names. So 5.3, write the name of CaO. Okay, seeing a lot of calcium oxides. All right, yeah, good job. You are all correct. It is calcium oxide. And the key thing, the key thing to look at here is this "ide" ending, right? This "ide" ending is what you add on when you're doing like ionic. So these are ionic combinations. So, sorry, ionic molecules. Calcium oxide, you always add "ide" whenever it's ionic. And it's super easy. You just put the name of the first one and then the shorthand of the next one plus "ide." All right, so with that knowledge, what is the name for MgI? All right, most people are saying magnesium iodide. Yeah, magnesium iodide is right. And this one, these are all easy because you only have singles of things. It's not like multiple. If it was written like this, and there was 2 iodides, then it would be a diiodide. But there's only one, so it's only singular. So.
So I was going to ask a question on that. These are all ionic, right? Because the indicators are the metals on the left.
Yeah. These are ionic. Another way to identify an ionic compound is it's going to be a metal with a non-metal.
Right. Yeah, that's what I meant. Okay. And so why would it then be? I thought with ionic compounds, it was always just whatever the next thing was with the IDE ending.
Yeah, it is. Oh, wait, sorry. You're talking about when I said diiodide?
Yeah, or even for if it like CaO, like I don't know if it was something else, if it was like Ca2O3 or something like that. I didn't check the numbers on that, but you know what I mean? Like it would that all be calcium oxide or?
Yeah, no, actually you are right. I like completely forgot. For ionic compounds, since they are ionic and they have to do with charges, the way this works out is that calcium is a 2+ charge. Oh, sorry, 2- charge. No, it is plus. And oxygen is 2-, right? So the reason you don't have to specify it's like 2 iodine if it were to be, or 2 oxygen, it's because no matter what the charge is, we always know the charge of these compounds because these are not transition metals. However, right, you see in this example, iron to hydroxide, it's going to be different because iron can have multiple ionic charges, so you have to specify. But no, you are right. If it were to be because the thing is, it would never be O2. It would never be CaO2 because it can't physically form.
Okay, but say for example, it was another combination where there are multiple of the second element, or maybe multiple of the first element or something like that, and it would still be an ionic compound. How would that be named? Would that just still be named like as if like calcium oxide, magnesium iodide, or would the name have to be changed, or would you have to like indicate like as it is with iron how many like the number, the positive charge. Like, does that sort of make sense? I can't.
Yeah. No,
Okay.
I understand what you're saying. And yes, you wouldn't have to specify because like, for example, actually we can pull up an example like lithium oxide. It's going to be Li2O,
Yeah.
but it's just called lithium oxide.
Okay. Okay. I see.
Yeah.
So then if you see that, then you know it's ionic then, I guess. Okay.
Yeah. Thank you
Thanks.
for bringing that up.
Thanks.
Good point. All right. And any other questions about these so far, or should we do the next one? Okay, so put in the chat what the answer is for this name, NaCl. This one's very easy. We talk about this one all the time. Yeah, sodium chloride, also known as table salt. Exactly. Oh. And yeah, another thing, just they all end in "ide." That's like the defining factor, essentially. All right, we got a question. Don't covalent compounds use prefixes and transition metals use Roman numerals? Yeah. So the whole thing with the transition metals using Roman numerals is because, like iron, for example, iron can either have a +2, +3, +4 charge, and you don't really know, like they're all called iron hydroxide, right? But it could have a 3, 4, or like 1 charge. So you have to specify with the Roman numerals if you're writing out in words. But when you have the chemical formula, you can just see it, so you don't need to specify, All right, so speaking of, what is the formula for iron 2 hydroxide? All right, we got a lot of people saying FeOH2. And yes, this is correct. I just want to make sure you're all careful when you write the OH2 because it does need to be in parentheses. Because if you were to write it like this technically means that this 2 is only applying to the hydrogen, not the entire hydroxide, like that. All right, any questions on this one? Do we all understand like why there are Roman numerals? Yeah, we can explain how to do it for sure. Okay, so let's restart from the beginning. So one key thing to remember is are metals positive or a negative charge? Positive, yes, you're right. So that's one thing, like a very basic knowledge that you need to just know. So metals are going to be positively charged, and hydroxide is the name for OH. So OH minus is called hydroxide. So here, we'll write it like this. Here, I'm gonna make it look nice so you can really see it. No. Okay. OH minus is hydroxide. And iron it can have, so a lot of people are confused as to why transition metals can have multiple charges. And it's good that you're curious about these things, but it's definitely out of your range for this class. If you really want to know, look it up, but I'm not gonna explain it to you right now because it's extra knowledge that you don't need to know conceptually for the exam, and I don't want to like stress you out. So just know that transition metals, like pretty much all of them, can have multiple charges. It has to do with the orbitals blah, blah, blah. It's very confusing. But so it's just a thing you need to know. And that's why you have the Roman numerals to represent the charges. So iron 2, so iron Roman numeral 2 equals like this. It equals iron to the positive 2 charge. If it were to be iron 3, it would be iron to the 3rd charge. Does that make sense? The number correlates to the charge. Yeah, so if it's confusing, just write it out in like words and then see what it means. And then it's the same thing as doing this, right? You see that iron has 1 charge and hydroxide has 1, -1. Iron has +2. So you're going to need 2 hydroxides to neutralize 1 iron. I hope that helps. Are we feeling more confident about this one? Alrighty, so let's go to the next one. Aluminum carbonate. What is your formula for this one? So we got one answer so far. Anyone else on this one? All right, this one looks like some people are, some people, we have quite a few answers, but let's break it up the same way we broke it up for the first one. So aluminum is the easy one. What is our ion that forms for aluminum?
Should be 3+, I think.
3+? Yes. And someone asked me, do we have to remember the polyatomic ions? And no, you will be given the polyatomic ion sheet.
The charges are included in the polyatomic ion sheet?
Yeah, charges
Okay.
are included. Alrighty, and carbonate is the next one. This is, since we've been talking about polyatomic ions, is carbonate a polyatomic ion? Yes or no? Yes, it is. It's an important one that you'll need to know, but it'll be given to you, so don't worry about it. So what is our formula and our charge for carbonate? CO3 to the -2 charge. Everyone agree with that? Yes, correct. So we have our 2 compounds, aluminum and carbonate, and we need to put them together, right? So this one doesn't fit as nicely as like the first one because we're going to have to do like find a common denominator. So between 3 and 2. So what, or I guess not denominator, sorry. I keep saying that, a multiple between 3 and 2. And that would be what? I saw someone said 6. Does everyone agree? 6? Someone also probably mentioned me. Yeah, right. It is 6. Right. All you do is just take the charges, flip them, and put them as subscripts. So aluminum is going to have what charge? Or sorry, aluminum is going to have what subscript? 2. And CO, we have to put it in parentheses. CO3 is going to have what subscript? 3, exactly. Yeah. Good job. And that's all you do for this one. It's pretty easy. It looks hard, but it's not that scary. Do we understand how to do this one? If there's any questions, please ask. All right, if you're ready to move on, can I get a thumbs up? Yeah. All right, we got a good amount. Let's move on to the last one, which is lithium phosphate. What did you get for this one? All right, we got some people saying Li3PO4. That seems like that's the only thing. We don't have any variation. All right, so you are all correct. It is Li3PO4. And we're gonna break this one up like we did the other ones. Lithium has what charge? Yeah, +1. And phosphate is a polyatomic ion. And what charge does it have? Yep, -3. All right. And then you put them together like we've been doing the whole time. This one's the easier one. And then you get your answer, lithium 3PO4. All right. Any questions for this first chapter, chapter 5, compounds and their bonds? Seems like we're, oh wait. So you could put it in parentheses, but it doesn't really matter because in this case, PO4, it's not having a subscript attached to it. Like for example, aluminum carbonate, that one, the 3 is applying to the entire CO3. But in this case, PO4, there's nothing that's being altered. So you don't need it necessarily, right? Because that 4 is part of that PO4. It would, if you were to put parentheses, it would be like this. But there's nothing, necessarily that you need. So you don't need to worry about it. All right. Gabe, do you want me to keep sharing or did you want to share?
I gotta. Did you get my text?
No.
Okay. Yeah. Basically, I'm gonna have to leave for now. I moved my session to Monday. So 2 to 3. I'll send an email about it later today. We'll have a quick review session right before your exam. And yeah, I'll send out recording and all that good stuff. But yeah, for now, I'll catch you guys later. And did you get the link, guys?
Yeah, or it's okay. We'll just go over them like the same way.
Awesome. Okay. Thank you guys. All right.
Bye.
Hopefully see some of you guys tomorrow. And if not, good luck in you guys' test. Okay.
Yeah.
Okay. Bye.
If you need more practice, good session.